All right, this function is a super famous function, okay? The sine of any a over a. It could be x over x, it could be whatever variable you're using, but it's a super famous function. And I need you to know, it's one of the ones now I need you to be able to picture in your mind what it looks like, okay? It is an even function, so it does have a side that we consider negative. So if you look at the second slide here, I've got the whole thing on there for you. Okay, it's an even function, so both sides are symmetric. For my allegory, I started it at 0, just because my time goes forward, not backward, but it does have a mirror image to it. Okay, so this graph will always fit underneath the branches of a hyperbola. So you'll have a hyperbola that's coming through quadrant 1. And where's the other part of that particular hyperbola? Okay, quadrant 3. So those two right there are forming the boundaries or the guidelines. The sine graph, this sine dampening sine graph will never stray outside of that. And so that is the y equals positive 1 over x. Okay, and on the other quadrants, in quadrants 2 and 4, they are also being dampened following the shape of a hyperbola there. Okay, and that's y equals, and that's just the negative 1 over x. Okay, so those form the boundaries. And if you can remember that, it's going to help you remember some important values of the way this sine graph works. Okay, this sine graph has limits. There are 3 limits you need to know and memorize about the sine graph. And again, if you can have the picture, you're pretty much going to have the value of the limits, okay? So the value on the left of this limit, so as we are out in quadrants 2 and 3, this sine graph is dampening where its amplitude is very, very small. It's getting smaller and smaller and smaller. So what's it basically hovering around? 0. It's hovering around 0. So we say that the limit value is 0 out in quadrants 2 and 3. Because it's hovering around 0. We call that oscillation is another word, where it's like a little above, below, but it's just do, okay? All right, the middle. The middle has a limit too, okay? It will never get higher than. Now, it doesn't follow the logarithm all the way up, because the logarithm goes all the way up to infinity. This sine graph has a peak right there, okay? And it peaks out at the number 1, which corresponds to the original amplitude. Okay, that's the original amplitude, that's the highest point. And then on the right side, again, out in quadrants 1 and 3, it's doing the same dampening thing. It's oscillating and hovering just right around the 0. So this graph has 3 limits, a left limit, a middle limit, and a right limit. Okay, the one thing about this middle limit that your calculator cannot show you is that there is an open hole right there. Okay, this is not filled in. There is a gap right there. So the limit is approaching the left and the right, but it will never actually reach the value of 1. Okay, there is an open gap right there. Okay, so knowing that allows you to make some pretty good hypotheses about what these other limits could be. Okay, if I throw a 3 into there, so now I'm asking you, what's the limit at 0? So it's a 2-sided limit. So at 0, both sides, what are they approaching if you throw a 3 in there? Okay, and the answer is 3. Okay, because that 3 fixed the amplitude or the potential amplitude, and so that 3 just basically covers the value for you. Yeah. Okay, so it's 3. It's a lot of this is like kind of gut reaction, what you think the hypothesis is going to be. We don't have to prove it. Okay, what about, oh, okay, she says 2/3. Okay, what's missing? What's different? Okay, there's a sign on the bottom instead of what? Instead of an X. Okay, so there's a sign on the bottom instead of an X. Let me just show you some of the algebra. Okay, we would like, in order for this to work, what do we need to do to dampen that? Not take out the sign. What dampened the sign? Dividing by X dampened the sign, okay? If we do this, and then that is over sine of 3x, and we have to also dampen it. Okay, is that legal? Okay, and the answer is yes, because you're dividing both by the same thing. Okay, that's legal. And so therefore, the value of this one is 2, and the value of the bottom one is 3, which is why 2/3 works. Okay, it's because if you introduce that x into it on both of them, then you're fine. Okay, let's try another one. How about tangent? Okay, Rose is guessing. Over. Okay. 4, 2. Okay. Well, what is tangent made out of, or where did tangent come from? Okay, so let's do a little experiment here. So this comes from sine of 4x over cosine of 4x. Using the same dampening technique that we just did, could we do sine of 4x, and could we dampen that with x? And then could we say that that's over the cosine of 4x, and can we dampen that with x, and then what would happen? Well, we know that in the top one, the behavior of sine is dampened and affected to the point where the answer to the numerator is going to be what Rose initially thought, which is 4. Do we have any proof or evidence yet about what happens to cosine? Okay, we don't yet. We haven't investigated cosine yet. We haven't gone to see what happens to cosine. Okay, we know what cosine of x looks like, but what happens to it when you dampen it? Okay, does it behave the same way that sine does? Okay, well, check it out. Okay, graph cosine on your calculator, and then dampen it with an x and see what happens. Okay, let me see what you get. Remember, we're looking at the middle. Okay, we're not focusing on what the ends are doing. We're looking right now. These are all around 0. Okay, we're looking around 0. We're not looking at the middle. What happens to cosine? Maybe you want to spread out your cosine to cover both sides, like from negative to positive, so you can check. Okay, it doesn't. Okay, so that's what I want you to see. Okay, in sine, the graph of sine, when it got dampened, looks like this. And then it starts to oscillate like that. Okay? It comes to a peak. The graph of cosine does all the same oscillation thing, but it doesn't do the same thing by coming to a peak. Okay? The graph of cosine, excuse me, whoops, goes straight up to infinity. Okay, it does not act the same. Okay, sine comes to where both sides, left and right, are coming to a peak. Okay, this one does not affect that, does not behave in the same way. All right, so all that to say, this was 4, but dampening it does not affect the amplitude, and it's still 1. So the answer at what Rose originally thought was correct. Okay. I'll have to prove that to you. You don't quite know enough math yet for me to prove that to you. She's just going to have to believe me that I'm going to show it to you in just a minute. Okay, give me a couple slides. Yeah. If you know that. Yeah. All right, here we go. How about this? What do you think the answer is? Okay, I heard 1/3. I heard 0. Okay, raise your hand if you think 1/3 is the right answer. Somebody said, what do you think 0 is the right answer?
Christian is smart.
All right, look at where it's going.
Oh.
Okay, look at where it's going.
Of course.
All right, so let's figure, this is not talking about the middle. It's not talking about the little peak anymore. It's talking about the oscillation that's happening where it's hovering all around 0. So let's think about this a minute. Okay, we would like it to be plain x, not 3x. We would like it to be plain x. So how can I get rid of the 3? Can't divide by 3, that's not legal. Okay. All right, 3 is where? Dividing by 3 is the same as, can you give me a little mantra? Dividing by 3 is the same as multiplying by the reciprocal. Okay. So instead of dividing by 3, couldn't I multiply by the reciprocal? Couldn't I say that this is the same thing as the sine of x over x and then multiplying by 1/3 instead? Isn't that the same? Okay. So now this dampens to what number?
0.
That dampens to 0 because we're talking about quadrants 1 and 4. And if that dampens to 0, what does that do to the 1/3? It wipes it out, right? 0 times 1/3. So the answer to this is not 1/3. The answer to it is 0. What would you change about the original problem to make the answer be 1/3?
Maybe x to go to 0.
If this one was x approaching 0, then the answer would be 1/3. But because the limit is approaching infinity, the answer is not. Okay, so those little arrows are important. Okay, how about this one? 5x plus sine x over x. Okay, you might have a gut about what you think that might be. Okay. Is it 5? Is it 6? Is it 0 like the other one was? Like, what is it? Okay, remember, we want it like this. Okay, we want it like that. Go ahead. Okay, we can work with common denominators. All right, if we want the sine of x to be separate over its own x to act as a dampening factor, then what does the 5x have to be over? Its own x, right? That's called common denominators. Okay, so what will this simplify to?
5.
Okay. What will the green circle simplify to?
Or 1.
Is it 0 or is it 1?
Infinity 2.
Okay, it's 0. When would it have been 1? Okay, if I'd be looking at the middle of the graph, it would be approaching 1, but I'm looking at the end of the graph where it's up and dampening, so the answer to that is 5. All right. Here is your dampened cosine, which you might need on a couple of your assignments tonight, or a couple of your problems tonight. So let's just talk about it. Don't quite, I can't prove this quite to you yet, because you need to know some things about derivatives. So we'll get there. So you just have to take my word for it today. Okay, so if you dampen cosine out on the left, then cosine of a over a will dampen to 0. And if you dampen cosine out on the right, that also will come out to be 0. But if you dampen cosine in the middle, on one side, what direction is it going? Okay, it's going to negative infinity. On the other side, what's it doing? Positive infinity. Those are one-sided limits, and those one-sided limits are not equal to each other because they're doing different things. So this one does not exist in the middle there, okay, for that particular one. All right, so, okay, so you have it, then you would do the same thing. But actually, this is a combination. All right, we want to take cosine of 2x, cosine of x, and its denominator right now is a 2x, which means over the 1, its denominator is a 2x, but we don't want it to be 2x. What do we want it to be? We want it to be just x. So how do we get rid of the 2? Same way we got rid of the 3 the last time. Say it again, multiply by the reciprocal. So if you don't like the 2 there, then pull the 2 out. So can I quickly just move? Shoot, it won't let me erase it. All right. So I have a cos x over x, and then I'll put the 1/2 next to it, and then 1 over 2x. All right, what will this turn into out at infinity? 0. Okay, so I'll have 0 times 1/2 minus, what will this turn into when I put infinity in? Okay, that will turn into 1 over infinity, which is also 0. So the answer to that is 0 minus 0, which is 0.